Okay, let's talk about real-world quadratics. So just story problems involving quadratic equations. And just a reminder, there are three ways we've talked about solving quadratic equations: factoring, square roots, and using the quadratic formula. So, and then some tips, just like solving quadratics, we're going to have to write a quadratic equation and solve it. So the tips for solving are still important for these. So let's just get to it, right? The first example here says the product of two consecutive numbers, remember consecutive means one after the other, is 90. Find the two numbers. So we just want to set up our consecutive numbers, right? If the first number is x, then the second number is x plus 1, because it says consecutive numbers. So remember, you want one variable for these. So you don't want to say x and y, because we can't solve that equation. You just want to have one variable. So in this particular case, our numbers are x and x plus 1. So we're going to multiply these, right? The product of our two numbers. So x times x plus 1 is 90, so equals 90. So what we should do now is simplify a little bit. So that's x times x plus 1. That's x squared plus 1x. And then we can subtract 90. So minus 90 equals 0. So now our equation is in standard form and it is ready to solve. Now we can solve by factoring or square roots, which doesn't apply here, or the quadratic formula. Quadratic formula always works, but in this case it might be easier to factor. So we need two numbers that multiply to 90 and add to 1, which are 10 and negative 9. So I'm going to use those. X squared plus 10x minus 9x minus 90 equals 0. So I'm splitting that 1x into 10 and negative 9. So if you can't remember how that works, check your notes from the factoring section of Unit 6, I believe. And just refresh your memory there. So factor by grouping here, x times x plus 10, and we can take out a negative 9. We get x plus 10. So our factored form is x minus 9 and x plus 10 equals 0. And now we have to find our solutions. Well, just remember from factoring, the solutions are the numbers that go here and here that make these equal to 0. So our answers for x are 9 and negative 10. But those aren't the answers to the problem. So remember, we're looking for two numbers that are consecutive and they add to or multiply to 90. These numbers are not consecutive, right? One's 9 and one's negative 10. So let's just pick the positive number, because remember our numbers are x and x plus 1. Well, if we eliminate the negative number, our answer is 9, and the consecutive number with it would be positive 10. So you'll see when you solve a real-world problem using a quadratic equation, you're going to get two answers. Typically, one of them will be the answer you're looking for, and the other answer will be like the negative solution that we don't need. So you can eliminate usually the negative answer, stick with the positive one. So our solution here, the answers to the question, the product, the two consecutive numbers, 9 and 10. Let's go to the second one. The length of a rectangle is 5 more than the width. The area is 104 square inches. What are the dimensions? So remember, if you have a rectangle, the area is length times width, right? And in our problem, we are given the dimensions in terms of the width. So if we have the width here for W, we'll call it, the length is 5 more than the width. So instead of writing L, we're going to write W plus 5, because our length is the width plus 5. It's 5 more than the width. So we want to write our dimensions here in terms of one variable, so that way we can solve it. And the area is 104. Well, length times width here is going to be W times W plus 5 equals 104, because our area is 104. Let me get rid of that. So now, just like the first problem, we're going to multiply through here and subtract 104 from both sides. So W squared plus 5W minus 104 equals 0. And now we have an equation we can solve. Might be kind of tricky to figure this one out because we have to go through factors of 104. It's got kind of a lot. Let's go ahead and use the quadratic formula here, just because I don't feel like figuring out what numbers. So W equals the opposite of B, and just a reminder, the quadratic formula is right here. So opposite of B is -5 plus and minus the square root of B squared, which is 25, minus 4 times 1 times -104, all over 2a, which is 2 times 1, or 2. Okay, now let's simplify. So W is going to equal -5 plus and minus the square root of, well, let's figure that out. 4 times 104 is 416, and we've got two negatives here, so that's going to be a positive 416, plus 25 gives us 441 in our radical, all over 2. Pretty sure the square root of 441 is 21. Yep. So our width, W equals -5 plus and minus 21 over 2. And if we figure those two numbers out, -5 plus 21 is 16 over 2 is 8. -5 minus 21 is -26 over 2 is -13. Well, the thing about a rectangle that has length and width, you can't have a negative width. It doesn't make sense. So the negative answer will eliminate here. So the width is 8 inches. A little smaller. So the width, 8 inches, and the length is 8 plus 5, right? The length is 5 more than the width. So 8 plus 5 is 13 inches. Which actually was the positive version of our answer there, but that I don't think will always work out, although it did work out on the first one as well. So just double check that. Don't just assume it's going to work, but use the positive answer and then you'll get the other answer as well. So 8 and 13 are the dimensions there. Okay, the sides of a square are increased by 5 meters. The new area is 81 meters squared. Find the new side length. So we have a square, right? And it's transformed into a larger square. We want to find the original side length, which we'll call x. Our new square, the sides are increased by 5, so those are going to be x plus 5, right? And the new area is 81 meters squared. Well, the area of a square is side times side. So basically we have x plus 5 times x plus 5 equals 81. So we have to do a little more math here. So x squared plus 5x plus 5x plus 25 equals 81. We can combine these and subtract 81 from both sides to get our equation in our nice standard form. So x squared plus 10x and 25 minus 81 is -56. All right. So we can try the quadratic formula or we can factor. And just to save some space here. I think I'm going to try to factor. So we want two numbers that multiply to negative 56 and add to 10. Well, 7 and 8 is not going to work. But I think 14 and 4 will work, right? 4 times 14 is 56. If we make the 4 the negative one, that will add together to get to 10. So x squared plus 14x minus 4x minus 56 equals 0. Let's factor by grouping. So x times x plus 14 minus 4 times x plus 14. So you have it, our factored form here, x minus 4 and x plus 14. So that means our two solutions for x are 4 and negative 14. Well, we want the side length of the original square, and the negative 14 just isn't going to work out. We can't have a negative length. So the side length, the original square, 4 meters. So there's our solution, 4 meters. So the solving part is very much the same as what we've been working on. The difficult part is going to be writing the equation and solving it. Now I've given you these 3 examples because the 3 problems that you have to do yourself are the same types. 2 consecutive integers, length and width, and then a sides of a square increased by 3 meters. So those are the same types of problems. Hopefully you can look through the work and do the same thing on these 3. If you need to rewatch the video, just rewatch that problem. And if you have questions,